All right, so in this video, we're going to go through sample question 106 from the Society of Actuaries, ExamP, list of sample questions. The question reads, let X and Y denote the values of two stocks at the end of a 5-year period. X is uniformly distributed on the interval 0 to 12. Given X equals X, Y is uniformly distributed on the interval 0 to X. Calculate covariance of X comma Y according to this model. All right. Pretty straightforward question. A little bit of a trick to it, but won't be too bad. First thing we should know is the formula for covariance. How are we actually going to calculate this? Well, the covariance of X comma Y is equal to the expected value of XY minus the expected value of X multiplied by the expected value of Y. Now, here's the thing. At this point, you should be wondering, okay, how are we going to get the expected value? In order to do that, we need the PDF. All right, so here's the tricky part about this question. We got to actually find the PDF first. So we know that both of these stocks uniformly distributed, right? Here and here. So the PDF for a normal uniform distribution is 1 over b minus a from the interval a to b. So the PDF of X is 1 over 12 minus 0, which is 12. Now, this word given, very important, because we're not getting the PDF of Y, we're getting the following. The PDF of Y given X. And that's on the interval, which depends on X, 1 over X minus 0, which is equal to 1 over X. Okay? Another formula you should be familiar with is that the PDF of Y given X is equal to the joint PDF of X comma Y over F, the PDF of X. Okay, multiplying to both sides, in order to find the joint PDF, I just need to find the product of this conditional as well as the PDF of F of X, right? Or the PDF of X. So F of X comma Y, right, joint PDF, is going to be equal to 1 over 12x. All right, so now that we have the PDF, we just go straight into all that annoying calculus. One thing I will note that can make this problem easier is recognizing that X doesn't depend on Y, right? It doesn't. So since it's uniformly distributed, we should know the expected value of a uniform distribution. It should be b minus a over 2. It should be 12 minus 0 over 2, which is 6. So we can real quick get the expected value of X equaling 6. Now, for the purposes of this video, because this is really meant to be an explanation, I'm also going to calculate it the way you would normally calculate an expected value. Okay? Because this might be something you don't initially see, especially in kind of a testing environment, right? Stress of the exam and all that. So the expected value of X is equal to, I do a couple of integrals. And what are my bounds of integration? Well, because Y depends on X, right? Because Y, like that interval contains X, I want that to be my inner integral, okay? So 0 to X, right? Because if I was doing dx first, my outer integral would contain X, not allowed. So this will go from 0 to 12, and it's going to be simply just 1 over 12, right? It's going to be what's in here, X, multiplied by the PDF, 1 over 12, X, which is just 1 over 12, and I'm doing dy dx. All right, nice little integral here, 0 to 12 of 1 over 12y from 0 to x, and that obviously just becomes 1 over 12x. dx. Okay, next this becomes 1 over 24x squared from 0 to 12, and we find this to be 6, right? So the answer is match. Okay, so now we're going to actually have to integrate for the expected value of y, right? Because it depends on x. We can't just use the formula for a uniform distribution. So the expected value of y is going to be, and I'm going to rewrite this fraction just for the ease of integration. I'm going to rewrite it as x to the negative first. I'm integrating 0 to 12 from 0 to x, 1 over 12, x to the negative first times y. And I'm doing dy dx. And this becomes 0 to 12 of 1 over 24, x to the negative first, y to the second, going from 0 to x. And this becomes 0 to 12 of 1 over 24x. Integrating this, I get 1 over 48 x squared, going from 0 to 12, and this gets me 144 over 48, which is 3. All right, so expected value of y is 3, and the final thing to do is the expected value of xy. All right, not too difficult. Expected value of xy is equal to, once again, integrate 0 to 12, another integral, that's 0 to x, and xy multiplied by 1 over 12x is simply just 1 over 12y. And once again, dy dx. This is 0 to 12, 1 over 24y squared, going from 0 to x, 0 to 12, 1 over 24 x squared, right, yep, and that's equal to 1 over 72, I believe. Yes, 72. 72 x to the third, going from 0 to 12, and this becomes 12 to the third, 1,728 over 72, which equals 24. Okay, now we can calculate the covariance. So, expected value of xy is 24. The expected value of x we found to be 6. Expected value of y we found to be 3. So this becomes 18 minus 24, or sorry, 24 minus 18, which equals 6. And that matches up with edge choice C. Okay, so overall, not a hard problem. They ask you, hey, calculate covariance. Easily. Write down this formula. These are the components you're looking for. And in order to find these, fairly simple, you need to know your integration, and you need to know that the expected value of a continuous distribution is the PDF, or integrating the PDF and multiplied by whatever's inside the expected value, right? You integrate the product of the PDF and whatever's inside the expected value. Now, in certain cases, they might not give you the PDF and you need to find it out. In this case, they told us there was these were uniformly distributed. You should have information about the for continuous distributions and discrete PDF, CDF, expected value, variance, and moment generating functions all memorized, right? Moment generating functions, maybe that's not your highest priority, especially if you're a few days out from your test. Don't worry about that too much, but definitely PDF, CDF, expected value, variance. You need to know those. You can't pass without them. But other than that, if you have any questions, throw it down in the comments below. I'll answer to the best of my abilities. If this video helped you out, hit the like button, subscribe. That very much helps me out. And if you want to see more problems like this, I have a playlist, Sample ExamP questions. Check it out. But other than that, thank you for watching, and I hope this helps.